Oh, hello there, guys. My name is Chris Fernandez. I'm the SC here in the Boston area for Keysight Technologies. Today, I'm just going to demonstrate how quickly and easy to do our new interface, which is the 10-base T1S. So right now, you can see on the screen here, I have two applications that we use. One is IxExplore, and the other one is IxNetwork. So I'm going to try to integrate, trying to show how to send traffic using IxNetwork. So first things we do here, on the background here, you can see that I'm already connected to the chassis, and you see the two interfaces here. Now I'm going to go into the IxNetwork itself and try to do the same thing. So I'm going to go and connect to the chassis itself, and I'm going to add those two ports to my session. So as you can see here, it read the interface, so I'm reading the two ports, and I'm adding the two ports to my session. As you can see here in the background here, IxExplore, I have it as my I already connected and I own that port. So when I go to IxNetwork here and I see that that port is being in use, all I have to do is just go in here and clear ownership. So that will clear the ownership for that port. You can see on the background here that happened, and then I have to connect that to my session. So if I try to grab a port that's not mine, I would just have to clear ownership and connect it again. So right now I pulled in those two ports for my session, and the way that IxNetwork works is that it has a default port media type. So I have to, in this case here, I have to change it now. So I'm going to change it back to what I wanted. So I'm going to set the figure here, and I'm going to leave it as is, and then I'm going to do the same thing on the port 2. And then after that, the ports should reboot and they should come up. And now you can see here there is still a bug on the IxNetwork on this release that I have here, which is a beta release. If you can read through the speed here, you can see the auto negotiate is on, and it says here it's 10 meg full duplex, but the IxExplore actually is the one that reads the information from that port itself, and the port is here. You can see read only, and the owner is myself on the other, and it's it's in the mode here, and PLAC is enabled, and I put in port 1 here as the node 0, so it's going to be the coordinator, and it's on 10 meg half duplex. So this here is the real configuration that the chassis is reading, not the one that is on the IxNetwork, and that's a bug. So on the port 2, if you look at the port properties here, it's node 1, so it's the follower, and so it should be working as 10-base T1S, supposed to be, right, half duplex. All right, so I'm going to go in here now. So I'm going to go back to IxNetwork. So now I'm going to create a scenario. So I'm going to create a scenario where I'm going to add protocols to it. So I'm going to use port number 1 here, and I'm going to use that port to create my stack on top, so I can do IPv4 traffic. So I just finish, and that will create 10 IP addresses on my port. It's going to be 10 hosts. So I'm going to use the ports. The ports are connected back to back, so they must be on the same network. So I'm going to just change the IP address here so I can create the same network. So that's the IP address that I'm putting on this stack here. On the prefix is 16, so I'm going to do so they can be on the same network. And the gateway, which is going to be the other side, is going to be 172.16.1.1. So, and I'm going to resolve the gateway. So now I have this configured here. I have Ethernet and IP on top, and I'm going to do the same thing on the other side. So I'm going to use port number 2 now, and I add that to my session. Same thing, I'm going to do IPv4. And on this side of the ports here, I'm going to use the 172.16.1.1 IP address. So I'm going to do 0 here. Same thing, same prefix, so they are on the same network. And I'm going to do the same thing here, 116.0.1, because now that's the other side. And I'm going to increment by 0 here. So now when I try to bring this up, so the first thing is when I try to bring protocols up, they're going to ARP. So the ARP should resolve. So for us to see that happening, we can actually go into captures here and control enable and control and start capturing on the control plane traffic before we do that. So I'm going to wait a little bit for capture to start, and then I'm going to start protocols. So start protocols is going to download the information and start protocols on both ports. So as you can see here, not all the ports came up. So when the ARP worked in one side but not the other, so what we can do here is stop and start again. So the ARP was going to be sent out again. Oh, sorry, there was a bug here on my configuration. I should have put this here on the host. That was the problem. I'll apply this traffic now, and everything should come up. So now I have greens on both sides. So the capture here, I'm going to stop the capture so we can take a look at the packets. So now looking at that, we should see a bunch of ARPs going back and forth from the both ports. So as you can see here, and this is the ARP that started here. And then the response is going to be over here somewhere. Yeah, after I fix that problem, then the response is going to come back in correctly. So anyway, everything got correct, defined correctly, and we're good to go. So now that we have IP up, we can actually send traffic. So let's create traffic now. I'm going to create IPv4 traffic. So I'm going to close the capture here that I don't need it anymore. And then we go into the traffic. So to create traffic, it's very simple. We're going to create traffic. So it's going to be from topo 1 to topo 2. So we're going to be one directional traffic. It's going to be the traffic type is going to be IPv4. So I'm going to go in here, and I'm going to grab the IP addresses here, and you can see that all the IP addresses that I'm going to do all of 10 of them. So I'm going to use all of them. And the destination for that is the other side, so it's going to be IPv4 too. I do next. I can do next. There's nothing here, so this is flow group. This is more for QoS and other stuff, so I'm going to skip this. I'm just going to click next. For the frame setup, I'm going to fix frame size of 512. For the pattern, what's in the packet, I can do custom, and I can do zeros. It's all zeros. And no CRC errors. The preamble is going to be automatically 8 bytes. For the line rate, I can send line rate, or I can send something in the middle. So let's just do 10% of line rate. So it's 10 meg. So it's going to be only 100 meg if we send that a 10% line rate, and it's continuous. Okay, next. For traffic flows, how are we going to identify the traffic flows? We can do it on the source destination address. So the traffic is going to be, we're going to keep an eye on for all the source addresses, for the IP addresses, for that. Doesn't change, but we can do that for sure. So here we can take a look at what is going to be created. So this is what is going to be created: the destination MAC address, the source MAC, and then the source and destination. And at this point here, we should be able to just validate everything looking good, and we should finish. So at this time now, we can actually send traffic. So we're going to start. We're going to apply traffic. Applying traffic means creating the traffic on the software and sending now to the FPGA for to be delivered, to be sent out. So we can start traffic now, and we should be able to see some statistics here in a few seconds. So we can take a look at port statistics here to see. So you can see here bytes are being transmitted already. And this is more of like in what rate we're sending traffic to. So you can see here we're sending at 0.1 meg, right? Which is 10% of the 10 meg rate. And then we can take a look at flow statistics and traffic item statistics. So those two here are being buffered on the background, so that's why we don't see it now. But we should be able to see it as soon as we stop traffic. So we can see that we are transmitting frames and we are receiving frames. Data integrity checks and everything is okay here. There's no errors. We can see no errors here. So let's stop traffic now. Actually, before we do that, we can start traffic again, and I'm gonna capture some traffic, some data traffic, not control traffic. So I can start. I can actually start capturing data traffic on the receiving side. So I'll start the capture there. I'm gonna stop and see if we're able to see some packets. So this is what we're sending and receiving. So this is exactly what we're receiving on the other side. So it should be just the IPv4 packets being sent out at 512 length, and everything seems to be correct. Checksum is okay. So I'm going to keep that out, and I'm going to stop traffic. And now I can go back to traffic here and try to read out, and now try to traffic item statistics here is showing now. So send and receive frames, there's no loss. And per flow statistics, we can see here how many packets were transmitted, how many packets we received. So we have no loss here. So everything seems to be working okay. So anyway, I just want to do a quick video demonstrating our new capability of sending traffic over 10-base T1S interface. All right, I hope you enjoyed. If you have any questions, of course, just reach out to us. Have a good day. Bye.